So let's see. Let's do the rigid motion one first. I'm assuming that's number 3. This one. Alright, that's the only rigid motion one I think. Yeah, that's the only rigid motion one I see. So I'm assuming you're talking about this one. Let me fix this. That looks a little better. It says you for the rigid motion one you're confused. 270 degrees. It just says that a sequence of rigid motion maps it onto it. You don't need to explain any of it. As long as you know which letters map on to which of the other letters, and the order which they write it is probably the best indication for you to figure out, which letters are mapping onto which. So it looks like A and J would map onto each other. It does look like a rotation, by the way. Could we say it's a rotation of 270 degrees? Maybe. It's not probably fully a rotation. It's probably it looks like a rotation and a translation of some sort, just like you meant. We can't figure out exactly how much because there's no actual coordinates. But as long as we know that A and J map up, B and K, C and L, and D and M. As long as we know that they map onto each other, therefore they are congruent, you should be able to figure everything out. So if A is 85 degrees, and we just said that A and J match up, so that means J is also 85. So they're just making sure that you're following the rule of correspondence, and so forth. And then you would go from there. B is 101. If B is 101, K is 101. And L is 123. I don't know why that's a typo. But L is 123. And what mapped up with L? Let's see. 123. So now you can find D and M. They're the same thing. If you know that a quadrilateral has 360 degrees, should be pretty easy to figure out from there. All right? So hopefully that answers the rigid motion question. Yes, we can go over the second one. I think Paige just had another question on the proof. All right, let me go to the proof. Parallelogram. Prove that the triangles are congruent. Oh, there's a ton of ways you can do this. You asked if you could do the reflexive property. Absolutely. Absolutely. If you're proving those two triangles, I think that's what I would do first. And then you can really prove these triangles congruent using almost any method except hypotenuse-like. So feel free to do really whatever method comes to you. Yeah, I think you can use angle, angle, side, side, angle, side. You can use anything because there's so much information from a parallelogram. You can literally use any property here. I see side, side, side. I see side, angle, side, angle, angle, side, angle, side, angle. I see all of them except hypotenuse-like. Definition of parallelogram. That's fine. I've never written that, but it's mostly fine. So yeah, I mean, I'm not going to take off for that. Usually I say in a parallelogram, then I say whatever the definition actually is. Like in a parallelogram, opposite sides are congruent. In a parallelogram, opposite sides are parallel. Usually I go those. But definition of parallelogram is fine. Yeah, that's fine. This is the one that you wanted to see? No, Abby, I did not watch it. I apologize. Alright, let me graph these. -3, -3. Oops. Let's see. Prove that triangle ABC is isosceles but not an equilateral triangle. So you're kind of proving two things here. No, I've not taken the chem test. You're doing two things here. You're trying to prove it's isosceles but not equilateral. And just by looking at it, it does look pretty close to an equilateral triangle. So I actually don't know which two sides are in fact congruent and whatnot. And whenever you're doing triangle proofs, slope usually is not the way to go, because especially for isosceles and equilateral. Slope would be fine for a right triangle. I think slope is actually easier for right triangles. But for any of the triangle stuff with the coordinate plane that you're trying to prove, just use distance. Just find the distance of all three sides. I'm not going to go through all three distances because I'm confident that you guys can do it on your own. But I mean, if you're trying to make sure it is isosceles and not equilateral, make sure two sides are the same, one is in fact different, and then just make sure you write a sentence to justify the math. That's really all you need to do. It's just like the parallelogram proofs. It's a coordinate geometry proof. This is probably a little bit easier because there's less math to do, and I think the concept's a little bit easier than, like, say, proving a rhombus or a rectangle or something like that. All right. So hopefully that explains how to approach that problem. Just do distance all three times. Find that two sides are the same, and that one side is different. Any other questions on the weekly? Let's see, I've gone over pretty much all but two. That's pretty good. And I think I even did explain this one at the beginning of the week. So hopefully if you're attending these or watching them later, that there are really no questions because I'm, pretty much giving out the answers here. So let's... That is due today also, by the way. And if there's no other questions, we can move on to what we've been working on, which is the angles with circles, and specifically exterior angles, where we have this rule right up here. I've circled it. That's kind of in general the rule. The larger arc minus the smaller arc, and then you divide by 2. Yeah, that would be workable. Can I re-explain number 6? Number 6 is a complementary relationship between sine and cosine. Because they use sine and cosine, and they've set them equal to each other, make sure that 3x minus 4 plus 55 is set equal to 90. That is the easiest way to get the value of x. 3x minus 4 plus 55 equals 90. That is that rule that sine A equals cosine B when A plus B equals 90 degrees. And usually I have you explain that relationship. This one just wants to find the value of x. So hopefully that helps with that one. Jumping back into this, we are going to do just that for all of these. Big arc minus little arc, divide by 2. We might have to go through some loopholes, figure out certain angles and whatnot. Maybe work backwards, something like that. We will see. So I'm going to actually jump right to number 15 because it's a little bit different than anything we've done before. 11:59 p.m. 11:59 is fine, just like chemistry. I don't put a time for the due date because I know a lot of people do it in the evening because I get a lot of messages asking questions Friday evening. So at the end of the day, so 11:59. In number 15, it says the measure of arc QU is what we need to find, which is that intercepted large arc. That's the large arc, and they directly give you the smaller arc as 46 degrees. And now this is a case where they've given you the angle, and I think that's the first time we're seeing that, where we're given an angle. Yeah, every other one we've done up to this point has been asking us to find an arc rather than an angle. That's fine, we can do that. We know that it's big arc, which in this case is QU. That's what we're looking for. But if you still subtract 46 from it, which tells us that we know that arc QU has to be greater than 46. And then if you divide by 2, when we do this math, we would get 35 degrees. And then we just need to solve from here. We're going to throw that 35 over 1. We're going to cross multiply. So we get QU minus 46 equals 35 times 2, which is 70. Then we're going to add 46 to both sides. And that's how we get the measure of QU to be 116 degrees. So obviously we can go backwards with these, which we did with the other ones as well. You're just going to set everything equal to whatever that angle that you have is. Number 16, right along the same lines. Find the measure of arc MK, which is the small arc. We need to find the, well, actually we have the big arc already. We don't need to find anything. We can directly start plugging in, but it does matter the order which you write this stuff in. And if you write it backwards, you probably just get a negative answer, honestly. And if you get a negative answer, just double check your work, make sure that you've plugged in everything properly. But since 160 is definitely the larger arc, the one the furthest away from the angle is always going to be the largest arc. So 160 degrees minus MK over 2 is equal to the angle, which is 56 degrees. We're going to throw that over 1, and we're going to do the same cross multiplication we did earlier. So we get 160 minus MK equals 56 times 2, which is 112 degrees. Just got to solve for MK. We got to subtract 160 from both sides. And just be aware, you still have a minus sign in front of MK, and that's fine. Everything will work out because you have negative MK, which we haven't really seen in a while. But typically when you're finding the smaller arc, this is typically going to happen. And then you have 112 minus 160, so you're actually going to get a negative result here on the right-hand side. And we get 48, or negative 48 degrees. But since you have a negative on both sides, you can multiply both sides by -1, divide by -1, whatever you want to do. You can literally just flip the sign. So you do get positive MK is equal to positive 48. Don't let those negatives throw you off. And we'll do one more on this page, which is find the measure of arc EF. And right away, I'm aware of kind of one thing. That arc has nothing to do with the formula set out for us. It has nothing to do with the big arc minus little arc. So I need some other kind of method to figure out what it is. And the only other piece of information I do have is the big arc, 191. But I also have that 77 degrees, and I'm aware that there's only one arc left in the circle, which is the small arc. So if we know those two arcs, if we know the purple one and the yellow one, we can easily figure out the one that we want, EF. So the purple one is really the one that the formula is going to give us as for an answer. So in this case, it's going to be 191 minus the small arc, which is FH, over 2 equals 77 degrees. And I'll throw that over 1. Again, cross multiply. 191 minus FH. 77 times 2 is going to be 144? I think so, right? No, it's 154. 72 would be 144. 154. And then we're going to subtract both sides by 191. And we get negative FH is equal to negative 37. So we do get the same thing as before. The double negative, we're going to flip them both to a positive value. And I'm going to put that in my diagram because that is not the final answer. We do need to figure out the value of the green arc. So what we're going to do is we're going to add up the purple one and the yellow one. So it's 191 plus 37. That entire arc, this arc, is 228. So we're just going to do 360 minus 228, and that's going to give us the correct value for what we're looking for, EF, which is 132 degrees. So the measure of arc EF is equal to 132 degrees. All right, so I mean we've done all of them except number 14 on this page. Hopefully we have a good sense of the rule. As long as you are comfortable with this kind of plug-in right up here, and we can remember that rule on top of all the other rules we've gone over, you'll be in good shape. All right, we're going to practice some more challenging ones, ones that are going to mix up the rules now. So at least all the different rules that we've done this week, Monday, Tuesday, and Wednesday. So you'll notice that in 1 and 2, it's different than all the ones on this page. And we're also using a little bit more algebra now. So for all of them, we're just going to be figuring out the value of x for most of these. Yes, I can go back. Hopefully that's good. But that's going to be the goal. We have to recognize what the diagram looks like and how we can apply whichever rule we need to. So we'll jump right into it. Number 1, you should notice that this diagram is definitely one of the diagrams we've worked with, and we have to know what that rule is. It's not big arc minus little arc in this case. Because that angle is in the middle, especially the one represented by 3x plus 23, this is the addition one. It's the two corresponding arcs to that angle, which are this one and this one. But it's addition instead of subtraction. We'll find both of these angles. Those angles are the same because they're vertical. So the rule says 75 plus 55. It's still dividing by 2, but now we're going to set it equal. Now we don't have an actual number. Since we're doing a little bit more algebra, we're going to set it equal to 3x plus 23, which is why we did all that algebra review earlier on. So now when we cross multiply, and the expression was originally in parentheses, and you'll notice I didn't write it. It really doesn't matter if you choose to write it or not. Just be aware that if there's an expression in a fraction like that, and you're going to be multiplying it into a number like this, even through cross multiplication, whether or not those parentheses were there or not, you need to distribute. Because both forms are technically correct. I could write it without parentheses, and this is still correct. Even if I write it with parentheses, it's still technically correct. Regardless, you do need to distribute everything by 2. So it's kind of one of the things we're going to have to look out for. So we're going to double everything. So it's 6x plus, also have to double the 23. So it would be 46. Is equal to 75 plus 55 times 1. I can just add the 75 and 55 right from here, which would be 130 degrees. I'm going to subtract 46 from both sides. We get 6x equals, what is that? Is that 84? Yeah. And then we can divide by 6 from both sides. We got x is equal to 14. So again, you just got to recognize the diagram based on, and figure out how you're going to apply the rule from there. Number 2, very similar diagram, therefore it's going to be the same rule. Make sure and identify everything in the diagram, make sure everything's in the right position that you would want. So the expression we know we're going to have to use to figure out x, but right here going across, they do give us the correct arcs that we would want, so you don't need to figure out anything else. So we're going to jump right into that rule, which says 159 plus 53 divided by 2 is equal to that angle. 8x plus 34 divided by 2. Oh, not divided by 2. I'm going to throw it over 1. And then we're going to cross multiply. $16x. So I'm going to cross multiply the x ones first. I'm going to double both of them. 16x plus 68 equals 159 plus 53, which is 212. Subtract 68 from both sides. Which is 16x. And then lastly, divide by 16, which we get, we get x is equal to 9. And that's the rule we use when the angle is in the middle of the triangle. Well, not in the middle, but anywhere inside the triangle. It is an interior angle. It's really all about that sign right in the middle. Whether you just need to choose whether it's addition or subtraction. You also need to identify the correct arcs to use. Number 3 and 4, obviously a very different diagram. Therefore, the rule is going to be completely different. And this one was similar to inscribed angles. Now, these angles are not completely inscribed because they are obviously they look different. Inscribed angles are ones that look like that, and clearly we don't have that. But it does follow a similar rule where you can double the angle to get the arc or cut in half the arc to get the angle, as long as it's the corresponding one that we have. So these two angles, or this arc and this angle, are related to each other, and they did give us those values. So again, that rule, you have two options. You can either double the angle, which means you have to double the expression, or you can figure out the angle by just taking that arc 140 and cutting it directly in half to get us 70. I like cutting it in half because it's just one number. You don't have to distribute. You don't have to worry about anything. So now I know you can take these two things, 6x minus 38, you can set it equal to 70 degrees. So 6x minus 38 equals 70 degrees. Add 38. 6x equals 108. Divide by 6. 108 divided by 6. 18. I'm going to try to go a little quicker through the algebra because I have faith that your algebra skills are fine. It's more about the new geometry rules and kind of applying it. Number 4. First thing that I notice is, do you have the things that you want in the correct positions? So look at the arc they gave you, which is this arc. 14x minus 22. But look at the angle they gave you. They said this angle was 23 degrees. That's not the angle that we really, really want. It's the angle that's directly next to it. So you have two options here. You could figure out the corresponding arc and double it. And then you could figure out the big arc by subtracting from 360. Or you could figure out the angle directly next to it from its linear pair. And I think we have more experience doing that, so we'll just do that. That's going to make this angle 167 degrees. But that's not the arc measure. That's just the angle measure. We need the arc measure simply just by taking this and doubling it. So you double 167. The arc measure is 334. Is that right? No, there's something wrong here. This should be 157. Right? Yeah, that makes more sense. So if that's 157, we can double that. That's 314. Yeah, that makes a lot more sense. The reason I was able to catch that because I knew this was 46 degrees, and I knew those had to add up to 360. Now I have the value that I can set the 14x minus 22 equal to. 14x minus 22 is equal to 314 degrees. So we can add 22 to both sides. 14x equals 336. And then we're going to divide by 14. Which should give us 24. All right. Now we go to the number 5. You identify the type of diagram that you have. You notice the angle is on the outside. So those are the rules that we just recently went over. So this is going to be a subtraction one where it's big arc minus little arc. So it's not addition because those diagrams look like this, like we did in number 1 and number 2. Very different from these diagrams. But now I kind of recognize, all right, this diagram, big arc minus little arc. And then do I have all the pieces in place already? Do I need to figure anything out? So we have to just kind of see. That's 161. That's the big arc. That is what we want. 65, that's the little arc, that's what we want, and the angle is labeled as 7x minus 1. So we're ready to just jump right in to our formula. 161 minus 65 divided by 2 is equal to, in this case, the expression 7x minus 1. We're going to throw that over 1. Cross multiply. So we have 161 minus 65, so that's 96. And then we're also going to double, I'm going to put the 96 over here. I'm going to double the expression, so it's 14x minus 2. Add 2 to both sides. 14x equals 98. And 98 divided by 14. X is equal to 7. Number 6. So here in number 6, we have same thing. It's a secant and tangent though, but it doesn't matter. I still just identify it exactly the same. I don't really care if it's secants or tangents. I know that the rule for this type of diagram is big arc minus little arc. But look at the corresponding big arc. That's the correct arc that you need. It is not labeled. So before you can jump into big arc minus little arc divided by 2, you are going to have to figure out the value of that one right there. But you do know the small arc, which is 86. And this is why they give you that 74 over there, because that 74 and 86 constitutes 2 of the 3 arcs that we have. So I would add the 74 plus 86 and get 160 degrees. And if we can simply subtract that by 360 degrees, and that will give us the value of the arc that we really need, the yellow one, which is 200 degrees. So the yellow one, 200 degrees. Now you can jump into big arc 200 minus 86 over 2 equals 4x plus 13. Throw it over 1. So 200 minus 86. I'm going to do that. This is 114. And then we're going to cross multiply this as well. So we get 8x plus 26 equals that 200 minus 86, which we just said was 114. And then solve for x. So subtract 26. Oops. So we get 8x equals 14, 12, 88, which that's going to divide out very nicely. 8 divided into 88 is 11. Oops. All right, so 7 and 8, they're going to be a little bit along the same lines. The only difference here is they're giving you more room for a reason. It's because they're going to give you more expressions. We also need to figure out the measure of arc AD rather than finding the value of x. So we are going to have to plug something in at the end as well. But let's label everything that they give us. So CB is 5x plus 41. Sorry, CB, so 5x, whoops. Then we have AD is 7x minus 19, so that's this one. And then AED is 89. AED is 89. So where's AED? That's right in here. And I'm going to highlight the piece of information that they want me to find, which is arc AD. Right? Arc AD. So that's this one right here. So I have a good idea, how I've marked everything, what I need as my answer. Obviously, you need the value of x, so you just plug in, figure out what it is. Keep in mind that like a lot of problems that we do, that usually there's, sometimes plugging into any expression will work. You have to plug into the 7x minus 19 because there's nothing saying that that angle is congruent to this angle. They are not the same. Number 2 that I want to do, identify the diagram. What kind of diagram is it? It's an interior angle one, so it's add the 2 corresponding arcs, then divide by 2. Step 3 is, do you have the correct elements that you need? And you do. Those are the 2 arcs that you want, so you can just start adding You'll have to combine like terms, but everything gets plugged in just like it would. Just because there's more algebra doesn't mean that any of the rules change. So it's going to be 7x minus 19 plus the other angle, which is 5x plus 41. All of that is still just divided by 2. The two arcs, divide by 2. And you're going to set that equal to the interior angle, which is 89 degrees. And throw it over 1. And combine like terms. 7x and 5x. So before I cross multiply, I like to combine like terms. Just simplifies the problem. So you get 12x, positive 41, and a negative 19. So you can do 41 minus 19, and you get 22, positive. Still over 2 equals 89 over 1. Cross multiply. So you get 12x plus 22 equals 89 times 2, which is 178. Subtract both sides by 22. You get 156. And the value of x, divide both sides by 12, you get x is equal to 13. But not done there. We do have to remember the thing that we're trying to find is the value of this arc. So we do need to plug in 13 in for x. So it is 7 times 13. Is that right? Yeah. Minus 19. And that's going to be the arc that we want, which is arc AD. So 7 times 13. It's 91 minus 19. So the measure of arc AD is 72 degrees. So you're probably starting to see why we practiced a little bit of algebra earlier, but this is why. And if we were taking regions, these are pretty common regions questions. They usually ask one along these lines, whether it be in multiple choice or extended response, and usually with this amount of expressions. And it's not that the algebra is hard, it's just the abundance of information that goes along with circles. And even though we've done a lot so far, there's still more to come, which we'll get into next week. All right, number 8. All three of these things are expressions. 1, 2, and 3. That's fine. Let's label them all. JM is 10x plus 9. Oh, I'm going to use a different color. 10x plus 9. NL is 28x plus 17. And angle NKL is 16x plus 19. Find the measure of angle NKL. So again, I like to highlight what I'm actually trying to find, so I know kind of in advance what I'm going to need to plug in for. It also gives you a good indication that you're not done when you find the value of x. It's good to know that in advance rather than reread the problem. You have no actual values here, but it doesn't matter. If you follow the rule, you should get to your answer just fine. Add the two corresponding arcs, divide by 2. It looks like we have everything. There's nothing to figure out, which is no surprise because they didn't give you any angles. Usually you can't figure anything out. So we'll jump right into our setup. So the two arcs, 10x plus 9 plus 28x plus 17 all over 2 is equal to 16x plus 19. We'll throw that over 1. I'm going to combine like terms first. So x's, whole numbers, you get 38x plus 26 divided by 2 equals 16x plus 19 over 1. Now I'm going to choose to cross multiply. So that's going to become, I'm going to go up here. I'm going to double 16, so 32x, double 19, which is 38, is equal to 38x plus 26. And I'm actually going to put the 32x on the other side instead of keeping x on the left-hand side because 38 is bigger. They're both positive. I just think it's nicer to work with positive numbers. So I'm going to choose to put x on the left-hand side. So I'm left with 38 equals 6x plus 26. And then I can put the 26 on the other side. You'll notice this way, I mean, either way will work. It just, this way avoids negative numbers entirely, which I think is just better to avoid. And you get 12 is equal to 6x, which makes it super simple. The value of x is 2. But we just got to plug back into the angle, which I can still see on the screen right there, is 16x plus 19. That's what's labeled in the diagram. We're going to do just that. So angle NKL is equal to 16 times 2 plus 19, which is 32 plus 19. The measure of angle NKL is 51 degrees. A lot more work for sure, especially when there's more algebraic expressions, a lot more to keep track of. But that is the solution. That's a great spot to end because we finished at least this page. There is more. We might practice. We're probably not going to go through all of these, but we will probably practice maybe a couple when we come back over the weekend, and then we're going to jump into something new, most likely. But that's kind of the plan. If you guys have any questions on the weekly or anything like that, feel free to send me a remind, and I'll try to answer you. I'll do my best to kind of explain it through a text message, I guess. If not, I can send a video picture or anything if anyone gets stuck. But most of the solutions have been shown on stream, so look back at the past streams. Can I go back again? I'm assuming you meant this page. And yes, I can. But we're all set. You guys have a nice weekend, and I'll see you on Monday. All right?